Slope. I'm sure a number of you have already heard of this term. You probably already know a lot about it, but maybe you don't. It is what it kind of sounds like. It's sloping, slanting. It's telling me how much something is slanted. Is it slanted not very much or a great deal? Is it slanted upward or downward? That's the intuitive idea. The mathematical formula for this is saying, okay, so you have a line that goes through point x1, y1, so this point here, and through x2, y2. So it's just two separate points. Then I want to calculate the slope, which is going to be the vertical change over the horizontal change. So the vertical change we sometimes call the rise. It's just the difference in the y's. I love that because the rise goes with y's, right? And then the horizontal change is the change in the x's. We calculate a change mathematically by subtracting. So that's where this formula y2 minus y1 over x2 minus x1 comes from. Let's take a look at an example. So here I have a line that's graphed and I'm asked to find its slope. Well, it's slanting upward, so that should give me a hint as to what kind of number I'm going to get, but let's actually calculate it. To do that, we want to find some nice points. By that, I mean points that I can tell definitely are integers, not going through kind of, I'm going to guesstimate it's 0.5 or 0.2 or whatever. So I'm going to choose 0, 2 right here on the y-axis and 2, 8 as my nice points. Once I have those, I follow our formula, which says you take the change in the y's, y2 minus y1, over the change in the x's, the 2 minus the 0, and we simplify and get a slope of 3. And that's a positive number, and that's telling to me. Let's take a look at the general situation. If I have positive slopes, I'm going to have lines that go upward. Now look at these lines, these equations here. The first one, this really steep one, is 3x. That's kind of like what we just saw. The next one is y equals 2x. And then this one is y equals x. They're all going up, but not at the same rate. If we change the equations and make each of those negative, now we still have some lines that are steeper than others, but in this case, they're all decreasing. So a positive slope indicates that my line goes up, and a negative indicates that it goes down or is decreasing. And the bigger the number, the steeper the line either way. There are a couple special cases, and those are horizontal lines and vertical lines. So a horizontal line is not going to have any change in the rise, so it has a 0 slope. A vertical line, on the other hand, has all kinds of different changes on the y's. It's the x coordinate that is not changing, and remember, it's rise over run, which is the change in x. If I'm dividing by 0, that's undefined. So a vertical line will have an undefined slope. A couple other special cases we should be aware of are parallel and perpendicular lines. So parallel means that they are going to go alongside one another and never ever intersect. Well, the only way that's possible is if they're slanted precisely the same way. In other words, they have the same slope. So parallel lines are going to have the same slope. Perpendicular lines intersect in a very special way. They intersect at right angles, also known as 90 degrees. Mathematically, we usually put a little box there to indicate that that is a right angle. So if I have one line that's going up, its perpendicular line will have to go down. It turns out, if we did a little math, that we would discover that the slopes of these two lines that are perpendicular are related in a unique way. That is, they are negative reciprocals. By negative reciprocal, we just really mean you flip it over and you change the sign. So if line 1 has slope 7/4, its perpendicular line, line 2, would flip that, make it 4/7, and make it negative, right? That's it. That's all there is to determining if something's perpendicular to another line. So if we're asked to say, are these two lines going to be parallel or perpendicular, we could graph it and eyeball it, but a more precise way would be to go ahead and solve each of these for y equals mx plus b form, and then compare those slopes. So in this case, I have a slope of 5 for the first line, a slope of -1/5 for the second line. So they're definitely not parallel because they're not the same, but they are opposite in sign and flipped from one another or reciprocals, so we would say these are in fact perpendicular lines. We could graph both of them in our calculator just to verify, but we don't need to. One last thing about slope. Slope can be used practically to tell us an average rate of change. So you hear any problems asking you find the rate of change, they're really just asking you to calculate a slope. They're asking you to calculate the ratio of the change in one variable to the change in the other variable. So in this particular problem, I have the population in St. Louis City in 2000 and in 2010, and I'm asked to calculate the average rate of change. One thing that we should note is that anytime I'm dealing with data that involves time or a year, I always consider the time or the year to be my x-coordinate. So in this case, if I'm going to find the average rate of change, I'm going to take the difference in the y's, which would be the populations, divided by the change in the x's. And remember, with slope, you always have to start with the same point. So if I start with 348 minus the 319 number, I'm also going to have to start with 2000 minus the 2010 number, right? So you have to go in the right order. In this case, that leads me to a negative answer. So if you remember from a couple minutes ago, when we talked about slope, if it's negative, that means it's a decreasing trend. So what this is telling me is that we are decreasing by 2,890 people per year. Now, where'd the label come from? Well, let's think about our original ratio here. These top numbers all involve the population or people, and the bottom numbers are involving the year. So I simply take the labels of my original ratio for slope and put it down here for my answer. Let me know if you have